Hello, my honors pre-calc people. So we do not have school today, Friday, as you already know. But what I want to do is I want to go through just a couple quick things from 8.7 that I was going to teach today. I'm going to do a very short, abbreviated version of it because we are still going to be testing on Tuesday. Collaborative is still going to be due on Tuesday. So just plan on that. On Monday it is a late start, so we will do a quick review of these notes in case anybody doesn't watch this video, and then you'll have time to work on the review problems that are day number 17 on your homework guide, and then Tuesday will be your test. The main thing that I wanted to refresh your memory about is the last time we met, we learned about determinants, and we learned that, if you have A, B, C, and D, that you would do upper left times lower right, so A times D, minus, excuse me, and then the other two multiplied together, B times C. And then we did a 3 by 3. We had A, B, and C going across, and we had x1, y1, z1, x2, y2, and z2, and that ended up equaling everything but column A, so y1, y2, z1, z2 times A, minus the determinant of everything but column B, so x1, y1, x1, x2, x1, x2, and then column C, z1, z2. That's times B, and then there's a plus sign, and then it's everything but column C, so x1, x2, y1, y2 times C. All right, and so what we're going to do is two problems, and that's all we're doing. So the first example is, let's say that vector V is equal to 2I plus 3J plus 5K. All right, and let's say that vector W is equal to vector I plus 2J plus 3K. All right, what you're going to do is we're going to be calculating something called the cross product. All right, we've learned dot product, and now we're going to be doing something called the cross product. The dot product, when we talked about dot product, remember it was, it looked like this. You did V, and then there was a dot, and then W like this. Cross product is going to look like this. You're going to have V, and it kind of looks like an old time sign or an X. So this is cross product. That's the difference between dot product and cross product. Cross product, what we're going to be doing is essentially this thing up here. Okay? So when we do the cross product of V and W, what we're going to do is we're going to make a 3 by 3 determinant. All right, and so we're going to have, instead of A, B, and C going across, we're going to do I, J, and K. And then we're going to basically put, vector V across the top, the next row, and W will go along the next row. So V, we had 2, 3, and 5. So 2, 3, 5. And then the second one goes on the last row. So W is going to be 1, 2, 3. 1, 2, 3. Right, and then we follow the formula up here, and we'll end up with some kind of a vector. Dot product, remember the result was a real number. This is going to result in a vector with like an actual I, J, and K. So what we're going to do is we do everything but column A, or in this case column I. So it'll be 3, 2, 5, 3. And then we put an I here. Then we have a minus, and then it's everything but the second column, so 2, 1, 5, 3. And we put a J, and then everything but the third column, so 2, 3, 1, 2, and with the K after it. All right, after that we're going to do the determinant, which again is the upper left times lower right, so you've got 9 minus 5 times 2, which is 10. When you subtract those, you're going to get negative 1I. Here, 2 times 3 is 6, minus 5 you get 1, and there's a minus already there in front, so it's minus 1J, but 1 is optional. 2 times 2 is 4, minus 3 times 1 is 3, you get 1, and there's a plus sign in front of it, so plus 1K. All right, and that would be your answer. All right, so that is how you do the cross product of something. Then, the other thing, the last thing I wanted to do with you real quick was talking about orthogonal vectors. Okay, an orthogonal vector. The results of a cross product, okay, so like what we just got up here, the result of a cross product is a vector that is orthogonal. Remember, orthogonal means perpendicular, so orthogonal, perpendicular, normal is another word that means the same thing. All right, so the result of a cross product is a vector that is orthogonal, perpendicular, normal to the two vectors that you took the cross product of. To the two vectors that you took the cross product of. And I'll explain that. Product of. All right, so when you take the cross product of two vectors, like we did up above here, v with the cross product of w, when we did the cross product of v and w, we've got this vector here. This vector that we got is orthogonal to v, and it's orthogonal to w. So this vector is perpendicular to v, and it's perpendicular to w. All right, so what's going to happen is you're going to end up with a problem that looks something like this. So this is our last example. It is find a vector orthogonal to vector v and I minus k if vector v is equal to negative 6i plus 3j plus 4k. So we're going to be finding a vector orthogonal to v and this I minus k. All right, and so what you're going to do to find a vector that's orthogonal is you're going to be doing the cross product. You're going to be doing vector v crossed with this vector I minus k. Okay, that's what we're going to be doing. So essentially we're doing the cross product of these two vectors. What we're going to do is we're going to set it up as a 3 by 3 vector like we did above. You've got I, j, and k. Vector v, the I, j, and k are negative 6, 3, and 4. And then the I, j, and k for this vector, 1 is in front of the I. There is no j, so we put 0. And the number in front of k is negative 1. I accidentally put k there. It should be a 4. Apologize. So this is going to be our setup. And then we're going to do the cross product like we did above. So to do that, we do everything but the first column. So we've got 3, 0, 4, negative 1. And that'll go in front of I. Then there's the minus sign. And then we do everything but column j. So negative 6, 1, 4, and negative 1. Right, and then we have the plus sign, and then it's everything but the column with k. So it'll be negative 6, 3, 1, 0. All right, and then we do the determinant. So upper left times lower right is negative 3, minus 4 times 0 is 0. So you get negative 3i. Okay. Then the next one we have negative 6 times negative 1 is 6, minus 4, you get 2. And there's a minus there, so minus 2j. And then we have negative 6 times 0 is 0, minus 3 times 1 is 3. We get negative 3k. All right, and so this would be a vector, this would be your answer, this would be the vector that is orthogonal to both v and this I minus k vector. All right, so that was the main thing. There's going to be a problem very similar to this on the test, so make sure you know how to do this. If you're looking for extra practice, you can look at the day 16 homework. There are some problems on there that you can kind of practice. Don't worry about number 54. 54 talks about a unit vector that's normal to the plane. I can show it to you, but it's not going to be essential for the test. So basically anything from 8-7, the day 16 homework except for number 54, you should be good to go. And then obviously you can start looking at the review problems as well if you would like. Collaboratives due on Tuesday, test on Tuesday. Thanks for listening, guys.